So we are GroKalp S2CNT. So GRO is from growth, Kalp is Brahma's one day. So GroKalp, you are growing forever with us. We focus on developing advanced materials, advanced systems, completely made in India, the whole supply chain in India. If equipments are not there, we design our own equipments. We are heavily supported by government. We got a lot of funds from them to develop these solutions. It will be highly technical, so if you are getting bored, you please let me know. So uh, there are three critical elements what we will discuss today. So first is multi-wall carbon nanotubes, second is hexa boron nitride, third is hexa silicon carbide. Now with these three materials, these are magic materials because every system has a problem that it is getting heated, thermal conductivity, electrical conductivity, tensile strength. You don't have the what you can say cooling system is not working. So these are the major problems with aeroplane, cars, laser weapons, whatever you need. So now here we have highly anti-corrosive properties, high electrical conductivity, very superior chemical resistance, and we are able to solve the first one. We can do mass production of multi-wall carbon nanotubes at a very low price globally. Second and third, it is easily available in India, so we are not going into that. So now we'll see what magic we can do with these three different nanoparticles. So now if you see that aeroplane when it flies in the height of 5 to 7 kilometers, there are super cooled water droplets in the range of minus 30 degrees. And these super cooled droplets just freeze on the surface of aircrafts. It will become ice and your aerodynamic efficiency is lost and you have a problem that you are not able to get the proper sensors. So we are using metallic heaters right now in aircrafts, and these heaters give you hot spots where you remove this icing problem. So we developed a coating with epoxy which can go up to Mach 2, and we have put multi-wall carbon nanotubes with some other chemicals, and with a little bit of electricity we can just heat the whole aircraft surface and you can eliminate the anti-icing problem. So we are working with DRDO on this. We have given the samples and hopefully it will be incorporated. So now laser weapon. The beauty of laser weapon is the biggest problem is cooling. When you generate so much of heat, your whole electronics will get fried. Now that much amount of heat you have to take it out, and right now what we understood, the Indian laser weapon system, they are using water cooling radiators. So if you use such an advanced system and use water cooling, then you will have a massive system sitting on a truck, and that is what you will see on the internet, what we saw the DRDO solutions. So now when we observe the Helios, what US is using, they are using paraffin wax based phase change materials. So now we studied that how what exactly is required, then we need two critical things which don't go together, that is high thermal conductivity and high latent heat. So you don't have those solutions. So with multi-wall carbon nanotubes and with few more chemicals, you can make very high thermal conductivity, extremely high, which can go up to 200, 300 with very careful nanoparticle engineering and paraffin wax like hexadecane and all. You can solve this. So this also we developed the solution and we offered it to defense that we can solve it and we can reduce the size of laser weapons and mount it on aircrafts or drones or ships. So this is one of the advanced solutions what is being used globally and people are working on it. You will not find this data online. So as there are a lot of defense teams available, so we thought let's showcase whatever is happening across the world. So now this is one of our personal favorite. When you are in minus 50 degrees Siachen and all, you have around 7 layers of jackets which you have to wear to survive, and it stops your movability. It creates a problem that it makes a lot of noise when you try to move around, and then you are just depending on passive heat, the heat what body is generating, and you are trying to retain that heat. So now we observe that with nanoparticles, with small amount of electricity, we can generate heat and you can eliminate few layers of the jacket. And as you can see the second photograph, the third layer is the nanoparticle coated cotton, which with minimum amount of electricity can give you up to 20 to 30 degrees delta over the environment temperature. And you can, with less layers and less weight, you can be there at a very comfortable temperature. So this is already being used or being researched in US. So we offered this to defense and we are working on this project right now for defense through Ministry of Textile. So this is our favorite because till now you saw maximum chemistry. When we try to work on stealth, we have to work on maths, physics and chemistry, all three. This, we have not developed the sample, we are just working on chemistry and physics right now and maths as well. So the biggest challenge if you see in the market is B2 bomber and B2 bomber stealth. If you know that radar cross section area of B2 bomber is 0.001 meter square. That is the gold standard right now. So we started working on what are available materials. So the classic vanadium oxide, boron nitride nanotube, silicon carbide. Then you basically there are 4 layers in these F-35 and B2 bombers, and they have different characteristics and coating techniques are very difficult, but we were able to solve the 4 layers what they are using. First is camouflage, that is IR camouflage. Second is resistive interfacial polarization, and third is magnetic absorption layer. Fourth is dielectric matching structure and base. So in a very layman language, photon particles are coming at some frequency. Now there are nanoparticles in these layers, and these bonds between nanoparticles, electrons, they are also moving at some frequency. So this photon particles frequency should match with the electron moving frequency, and then you have resonance and you have eaten away the energy which photon particle is carrying, so you are not detectable on the radars. So this is the whole science behind it. Now you have to identify what bands are coming and what is the frequency of those bands and how you can eat away that energy so that the reflection doesn't happen. So with these 4 layers, we are able to touch 99% reduction in the cross section area on a simulation basis. But the real gold standard is 99.9% what is B2 bomber is doing. So we had multiple discussions with Air Force, and let's hope we are able to move forward and do something with them. So yes, we discussed a lot about inconel, titanium, nickel in the morning. So now rockets, we are using small rockets, big rockets, and we are using rockets to hit drones. So we have to somehow reduce the cost of rocket because you are destroying 2 lakh, 3 lakh rupees drone with a 10 lakh rocket missile. So we have to use stainless steel, aluminum wherever possible because we cannot keep using nickel and keep destroying low cost warfare what enemy is using. So we developed one coating. If you see the thruster of rocket, which is the third drawing, it uses the film cooling, which is the second diagram, where we lose around 3% of efficiency, and we incorporate very complicated designs. And because of this thruster is usually using inconel or far superior materials, sometimes haste alloy. So by using stainless steel and hexaboron nitride coating mixed properly with silicon carbide and multi-wall carbon nanotubes, you ensure that we are going up to 2000 degrees Celsius. It can sustain. You doesn't have friction because of the hot gases which are going through, and multi-wall carbon nanotubes give you an even heating across the surface. So these trials will happen next week hopefully, where we will use stainless steel instead of inconel or nickel or haste alloy, and we'll do a coating because the whole cycle of a rocket is around 90 seconds, whatever we are designing, right, working with the company, because in 90 seconds it will hit the target or it will consume the whole fuel what is having. So the whole coating has to survive 90 seconds, and we cannot and when you use stainless steel, you are able to increase the payload by 10% because your inconel is very heavy, and you reduce the cost as well. So these are like one of the good solutions what we can use different type of coatings to reduce the costly materials and use lighter materials. This is, we were working, but Korea came first. So these two second and third image what you see is the Korean images. So now copper, we can replace copper with nanoparticles. This motor is made without copper, and it is completely made with nanoparticles. It is 80% lighter. It doesn't heat. It uses less battery, and if you are able to use this motor in your Rustam, you can sincerely increase your payloads, and it can fly for a longer duration. And nanoparticles, they are known as nanoparticles because they are nano in shape, but with wet spinning method we can make wires out of it, and then we can do proper coatings over that, which are insulators, and we can make motor out of it, and we can eliminate copper. So the world is moving towards eliminating copper because solutions are available. Similarly, we can focus on how we can remove the costly materials. Instead of producing more, we can use different type of coatings, different type of additives, and using some chemistry, we can try to eliminate where non-critical parts can be made with cheaper materials and lighter materials. So thank you. This was a small presentation. I will leave with last message that I have met Chinese ecosystem, I have met Russian ecosystem, American ecosystem, and European ecosystem. I promise you, Indians are not behind in science. We are behind in maybe team spirit. So we request defense forces offload all your headaches, offload whatever you want to offload, and you will find in 1 month somebody standing in front of your gate with a solution. So Indian startup ecosystem is eager to work with you, and yes, so we can definitely working together. We can be the #1 team across the world. We have the knowledge. We just need the team spirit, so that we work as a team. And thanks a lot. Jai Hind, Jai Bharat.